So the last bit of partial fractions is when we have a repeated factor on the bottom of the fraction. Okay, so in order to do something like this, it's very similar. We're going to write it as 3x plus 5 over x plus 1 squared, x plus 2. When we split it into partial fractions, I'm going to have something over the x plus 2. I want to have something over the x plus 1. However, I also need something over the x plus 1 squared. Now, it's important we have the x plus 1 and the x plus 2 for reasons you'll see when we multiply up in a second. Okay, but it's the same thing as before. So we're going to times both sides by the denominator here. So x plus 1 squared times x plus 2. And we're going to get left with, on the left-hand side, we're going to get just the top, so 3x plus 5. On this side, by times this fraction, by x plus 1 squared, x plus 2, the x plus 2's will cancel out, so I'll just get x plus 1 squared. When I times this one, by x plus 1 squared, x plus 2, one of the x plus 1's will cancel out, so we get left with one of them, and the x plus 2. And then for the last term, the c, when I times that, by x plus 1 squared, x plus 2, the x plus 1 squared cancel out, so I just get left with the x plus 2. And it's the same idea as before. Pick your magic numbers to make these brackets 0. So for this one, x equals minus 1 is a good first choice. So if I sub it into the left-hand side, I get minus 3 plus 5, so 2. I'm trusting myself, not using the calculator. If I sub minus 1 into here, this becomes 0. Minus 1 into here, this becomes 0. Minus 1 into here, minus 1 add 2 is 1, so I just get C. So therefore, C is 2. Okay, next magic number for this bracket, x would be minus 2. So if I sub it into the left-hand side, 3 times minus 2 is minus 6. Add 5 is minus 1. If I sub minus 2 into here, I get minus 2 add 1 is minus 1. Squared is 1, so I just get air. Minus 2 into here turns to 0. Minus 2 into here turns to 0. So I'm just left with that. So therefore, is minus 1. Now, we've got an issue that we've used both these numbers, both these brackets. So all I do is I just pick a random number and sub it in. So if I haven't used 0, that's the easiest one. I will always try and use 0 first. If I've used 0, I might try 1 next, or 2, etc. So if I sub 0 into the left-hand side, 3 times 0 is 0, add 5 is 5. Sub 0 into this side, 0 add 1 is 1, squared is 1, so that's just air. If I sub 0 into here, I get 1 times 2, which is 2, so 2b. If I sub 0 into here, I get 2, so 2c. Well, we know that air is minus 1. We know that c is 2, so 2c must be 4. So I've just got an equation now. So minus 1 add 4 is 3, 3 add 2b, so 2 is 2b, therefore b is 1. So I've got my three numbers, so I can write out my answer. So 3x plus 5 over x plus 1 squared, x plus 2 is equal to, well, a was minus 1, so minus 1 over x plus 2. B was 1, so 1 over x plus 1. And C was 2, so 2 over x plus 1 squared. Now, the important bit, why we needed the x plus 1 squared, is if I didn't have those, imagine I didn't have that term there, then when I times it by this, I wouldn't be able to get my linear term here. I would end up with a quadratic, in fact. Okay. One more. So if you want to pause it, you can try this one yourself first. Okay, so same thing. I'm just going to double check that this one is not an improper fraction. So the degree on the top is 2. The degree on the bottom would be 3, x cubed there. So it's fine to go ahead and do it straight away. So I'm going to write that as something over x minus 4 plus something over x. But this time I also need something over x squared. Okay, then I'm going to times it all by x squared, x minus 4 to get 5x squared minus 9x plus 4. And on this side, this first term will cancel out x minus 4, so it's getting x squared. The second term will cancel out one of the x's there, so I'm just get left with 1x and then x minus 4. This term here would cancel out the x squared, so I just get x minus 4. Choose your magic numbers to sub in. So for the first one, x would be 0. So the left-hand side, I just get 4. And this side, this would be 0. This would be 0. This would be minus 4. So minus 4c. Therefore, c is minus 1. Next number is x is 4. So sub 4 into the left-hand side. So I'm going to use my calculator to check it. So 5 times 4 squared. Take away 9 times 4 plus 4. So 48. This side, 4 squared 16. So 16 there. 4 into here will be 0. 4 into here will be 0. So therefore, it's just 3. Okay, now I would pick any number I want. So I've already used 0, I've already used 4. So I can't use 0 again. So I'm going to use the next easiest number I can think of in 1. So 5, take away 9 is minus 4. Add 4 gives me 0. So the left hand side is 0. 1 into there just gives me 1a. 1 into here just gives me minus 3 times 1, so minus 3, so minus 3b. 1 in here just gives me minus 3c. Subbing in numbers we know. So I know a is 3. I don't know b. I know c is minus 1. It's times by minus 3 is plus 3. So 0 is 6 minus 3b. So 3b is 6. Therefore, b equals 2. So my final answer, so my original fraction is, well, a was 3, so 3 over x minus 4. b is 2, so 2 over x. And c was minus 1, so minus 1 over x squared. Now, just to quickly show you how you can check that on your calculator in an exam. So if you go into graph mode, if I just type the first graph in, so it's lots of typing for this bit, but it doesn't take too long. X squared, x minus 4. And then on the other graph, type in what I said my answer is, so 3 over x minus 4 plus 2 over x minus 1 over, over x squared. Draw that, and the two graphs should be identical. There we go. You see that? The blue and the red is the same graph. Good.